Okay, so this is the final question of the free response. And again, the idea here is that you've worked through the first two of these, both no calculator, as is this one, and that you check those first two with the solution manuals. This one we're going to work through step by step, and then we'll put points to it as we go. This one's kind of a unique Taylor polynomial question, so it's not asking for you to use any kind of known function or manipulate any known function. It's just asking for you to operate on the general Taylor expression. So, and I'm just going to write that over here. So our general Taylor expression, and this one's centering around 0, so it's actually a Maclaurin, but they're calling it a Taylor centered around 0, is the nth derivative evaluated at 0, x minus 0, so just x, to the nth power over n factorial. These are what the terms look like. So this is just a parade of terms all added together, or added subtracted, depending on the coefficient. And we're going to be using that within this problem. So on the first one, it's known that f of 0 is -4, and then p sub 1 at a half is -3, and that's where this one gets a little more challenging. Then show f prime of 0 is 2. So we're looking to demonstrate that the first derivative evaluated at 0 is 2. Well, just thinking about what a Taylor expression is. So if we're looking at part A, a Taylor expression is saying we have a way to approximate the function. So if we're going to write a Taylor polynomial, we have some Taylor polynomial that approximates the function. So we've got our function defined as f of x, and we know f of 0 is -4. So that is the first term. If you think about plugging in n0 here, that's the 0th derivative evaluated at 0, x to the 0 over 0 factorial, so those are both 1. So our first term in our expansion would just be the function value. So and I'm just going to write f of 0 there, and then we've got a plus. What would that be? It'd be the, if we put in a 1, it'd be the first derivative, so f prime of 0 times x to the first divided by 1 factorial, or 1. I'll put that there, even though we really don't need it. That then is an equation that involves f prime of 0. So we're actually looking to figure out what this is, or show that that's 2. As challenging as this one can be to read, this is the piece of info that we're going to be operating on. So we're looking for, that's our p of 1, evaluated at a half. So this is our first order. That's what that 1 means, an n of 1. Or our power is 1, has a 2-term expression, and we're going to evaluate that at a half. So I'm going to take and plug in a half. Well, f of 0, let's see, we know that's, what is f of 0? That one they said is -4. And then f prime of 0, we don't know. That's what we're looking for. So we're looking to show that one. And then x, and I'm not even going to write the 1 factorial under there. So this is actually the thing I'm operating on. So that's -4 plus f prime of 0, which I don't know, times, and again, I'm putting in a half for x. So that's the only place that needs to show up. And then this whole thing they're saying is equal to -3. So that's what p of 1 of a half equals. So then I've got this equation. What would that be? It'd be a half times f prime of 0. So I'm going to add a 4 over, I get 1. And I'm going to multiply both sides by 2, and I get 2, and then that's it. That's f prime of 0. So I've demonstrated that f prime of 0 is equal to 2. And on this one, there's nothing more for us to do. They're going to give us a point for coming up with the 2-term expression here. And then they're going to give us a point for verification, which is this set of steps. So those are our 2 points on this problem, or this piece of the problem. In part B, so we'll scroll up a little bit here. I think we can make it to here and we'll be okay. It is known that the second derivative is -2/3 and the third derivative is 1/3, so find P3. So let's see, I'll switch colors here. Let's go red. So in part B, if I start with, I already have 2 terms to this thing, so if I'm looking for P3 of x, I've got -4, that's the first term. I've got, now I know that I've verified that my coefficient is a 2 on the second term, so that's 2x. And then we're going to use that same generic structure for all Taylor polynomials. So I'm going to go, let's see, I guess I'll go negative because it's a negative. It'd be 2/3, so that's our second derivative evaluated at 0, times x to the second power divided by 2 factorial. And then I need to do one more of those, so I'm going to go plus they give me the third derivative is a third, so 1/3 x cubed over 3 factorial. And so I've got my 4 terms, so my up to the third power, so my p3. And we can clean this up a little bit in terms of how we express it or write it. We could say -4 plus 2x. Let's see what this would be, minus 1/3 x squared, because 2 factorial is 2, so we're dividing 2/3 by 2. And then this one would be 1/3 over 6. This would actually be 1/18 x cubed if we clean that up. And this one ends up being worth 3 points. And the way they break the 3 points out is you get a point for the first 2 terms, and then you get a point for the third term and a point for the fourth term. So kind of an odd point breakdown, but that's how they chose to do it. So 2 points on the first one, 3 points on the second one, which means our last problem, or our last part of the problem, part C, is going to be worth 4. So the function h has a first derivative given by h prime is f of 2x. So they're linking this new function that they're introducing in part C. So this function h, they're linking it to the function that we're talking about here, which is function f. And they're saying that it's equal to f of 2x. And then it's known that h of 0 is 7, so we're probably going to have to use that somewhere. Find a third degree Taylor polynomial for h about x equals 0. If we want something for h and we're given h prime, to me, first thing I'm thinking is integrate. I'm going to need to integrate. So I'm going to need to take both sides of this thing and integrate it. By integrating the left, I just get h, and by integrating the right, I'm going to get an expression. And we need to generate a third degree polynomial, and then we'll figure out how to bring in this h of 0 is 7. So again, h prime is f of 2x. And let's change color again. So for C, I've got h prime is f of 2x. And we're going to integrate both sides. So I want to integrate this thing, but I'm only after a 3 to the power of 3 expression. I'll scroll back up and make sure that's accurate. So we want a third degree, so we want to get to the power of 3. So I certainly don't need any additional terms, and if you think about what integration is doing, we're going to take each of these 1, 2, 3, 4 terms, we're going to integrate them individually, which means the powers are going to get bigger on each one. So I actually don't even need this last term when I integrate, because by powering everything up, that one will become an x to the 4th, and we'd actually end up not using it. So what I'm going to do is I'm going to write out what h prime is. I'm just going to take out everywhere where x shows up. I would take out and put in a 2x. So I'd have -4, that's not going to change, 2 times 2x, and I'd have 1/3 times 2x quantity squared. And even though, that should be a minus, shouldn't it? Minus 1/3. Even though I don't need it, just for the sake of writing it, I'm going to put it in there. That's what we would be doing. And there's actually a ... here. I mean, it keeps going. But now what we're going to do, and I suppose I could simplify this expression a little bit. That'd be -4 plus 4x. This would be minus, what would that be? 4/3 x squared. And if I was doing this, it would be plus, let's see, 8/18. And I'll just write it as 8/18. I won't simplify it because we're not going to be doing anything with that one. And now what we're going to do is integrate both sides. So we integrate both sides. When you integrate the left side, you just get h. And when you integrate the right side, all of those are going to gain a power. So it'd be -4x. It'd be 4x squared divided by 2. And it'd be, what would this be? 4x cubed over 3. Or another way to write that would be 4/3 times x cubed over 3. And again, we could do this last term, but we don't need to because it's going to give us something with a 4th power in it. So we're going to stop it there, and then I have to remember to put my plus c on there. Always when you integrate with a plus c. So I'll clean this one up a little bit. It would be -4x plus 2x squared minus 4/9 x cubed plus c. And we have to go and solve for c, and that's where that initial condition they gave us, which seemed like a little bit of a throwaway up top, or at least something we didn't initially need, where they said h of 0 is 7. So h of 0 is 7 means, okay, take that and figure out what c is. So plug in a 7 here. These are each going to 0 out, and then c is 7. And then our expression for h of x would be our negative 4x, 2x squared minus 4/9 x cubed plus 7. And if it feels better to you to reorder that, and you think of just for the sake of ascending or descending order, you just feel better about putting that 7 first. You certainly can, or you can arrange the powers in any way you want, but that's what they're going to be looking for. So they give you 2 points on this one for just doing this initial 2x substitution. So I guess getting it to right here would be your initial 2 points. They then give you a point for all 3 of these terms, the non plus c terms, and then they give you a point for, there's a point, and then they give you a point for correctly coming up with plus c. So this one ends up getting 4 points attached to it. And that's really it. This is a different feeling question than some of the Taylors they've asked over the years. And I actually think a really fair representation if they're asking how to do just a generic Taylor series and operate on it.